Howdy, I'm Aaron Montana, the Experimentation Solutions Specialist at LaunchDarkly in our Center of Excellence. What if you could have insightful and reliable information every time you make a decision that could affect your company's bottom line? What if you could foster a culture of learning that made everyone in your organization feel safe to explore creative or even disruptive ideas? You can with experimentation. There are many valuable pillars to experimentation, but these are the three that I always like to highlight. First of all, experimentation drives financial gains. It improves ROI, and that's one of the main intents of it. You do this by collecting small marginal gains and the occasional big win. And this is common in experimentation. Big wins don't happen all the time, and when they do, they're super valuable. But more often than not, you'll be having small, incremental, marginal improvements when you run experimentation. This also means that you're reducing the amount of risk to your bottom line as well. And that makes experimentation very powerful for any organization, large or small. The next is a culture of learning. Fostering a culture of learning within an organization is incredibly powerful. It teaches and trains your team members to attach data to their ideas. Whenever they have a new idea, they know they'll need to provide a measurable outcome for that. It also creates a framework for them to fail safely and feel comfortable doing so. Most of us do not feel comfortable failing. But when you have a culture of learning, we feel that we're actually learning instead of failing. And finally, continuous improvement. This is something that we see in all of the market leaders in most of our industries. Continuous improvement has become part of the DNA of these really large, successful organizations. They focus on always improving the things they put in front of their users and continuously doing that through the lifetime of everything they do. Experimentation can be powerful, but you have to get it right. Join me now as we discuss some of the best practices for running an experimentation program at your organization. We'll start with a discussion of the planning process. Then we'll cover some tips for executing experimentation the right way. Next, analysis and understanding results. Finally, presenting your findings. Everything we'll cover in this session is meant to apply to any team using any tool for experimentation. Every company is different. Every company has different challenges, goals, and problems to solve. The experiments we run come from the steps we take to solve problems standing between us and our goals. When we practice hypothesis-driven experimentation, it's common to try and use our organizational goals as the primary metric to measure our success. Rarely does this make sense. Many factors contribute to these lofty KPIs, goals, etc. Instead, we need to choose primary metrics that have a direct and measurable effect on the problem we have identified. This allows us to have confidence in our data and ultimately the decisions we make using that data. Experiments should have a primary metric that is determined by the measurable outcome of your experiment. This is typically embedded into the hypothesis that you've written into your test plan. Take these steps in the planning phase to ensure that experiments have reliable data that can be used for data-driven decision-making before you ever press start on your first experiment. Determine which metrics you can effectively measure to contribute to your organizational goals. Find formal agreement with stakeholders before conducting experiments. And because the primary metric is the measurable outcome for your experiment, state the primary metric clearly in your hypothesis.
Here in the LaunchDarkly dashboard, I can begin tagging our metrics now that we've come to some formal agreements with the stakeholders in the organization. This total order value metric, for example, can be tagged as a Q4 goal so that it's easily identifiable. This numeric metric will allow us to track the total order value in actual dollar units. And of course, we're looking for a higher than baseline representation to show us if an experiment was successful. You'll also notice that it's tied to a user context, but I might also tie it to other contexts, such as vendors, where it would make sense. As I save the metric, one more thing you'll notice, this experiment is already using this metric, and as the metric is added to other experiments, as it is likely to be, those will begin to appear here as well.
With your primary metric and hypothesis in hand, the next step is to create a test plan. Test plans should be created for every experiment. These formal documents are an important part of the experimentation practice. A detailed test plan provides context and implementation details to everyone involved in the project, and expect plenty of different roles to be involved. Experimentation is cross-functional by nature. The kind of cross-functional work requires detailed information for everyone. Another aspect of test plans, replication. An ideal test plan contains everything you need to replicate a test. This is an important foundational concept in science. Here are some tips for creating a test plan document that will be a true resource for your team. Include a problem statement as well as the hypothesis. This way, everyone reading a test plan has full context for the purpose of the experiment. List all standard information about the experiment in a brief table at the top of your plan. This allows quick reference for anyone looking at the document. I like to include details about what platform the experiment will run on, such as desktop, mobile, or server-side, or what teams are involved in executing the test. Define each metric that will be included in the analysis, the primary, secondary, or any behavioral metrics that should be included when looking at the results. Finally, include implementation details as well as design assets to give even more context. Screenshots, mock-ups, architectural diagrams, anything that can be used to replicate this test in the future.
Here's an example test plan. You can see the name of the test listed, and right at the top, the problem statement, so that everybody who reads the test knows right away what this test is really trying to solve. You can also see here I've created a table for some of the common information, like what team owns the test, the name of the experiment, the type of test it might be, including what platform it could be running on, how long we might run the experiment, and even a place to mark the level of effort for the implementation, something probably done by an engineer or an engineering manager involved in the process. I'll also list the hypothesis right here, which will include some of the information about the metrics we'll be measuring, but we'll have more details about that farther down. And a place to put interesting details about how the test will be implemented and what each of the variants will actually look like. This looks like it's probably a mobile test, or at least we have mock-ups for it in this example. A little farther down, we'll get into who the audience and the targeting is for this test to make sure that that's clearly known. And then in another table, we'll list all of the metrics that we'll be tracking in this experiment. And we'll also make sure there's a place for sign-off that these metrics are actually being collected properly and whether or not they already exist or need to be tracked net new.
You may have heard of the term holdout group. A holdout group is a sample of users or contexts that you exclude from all your experiments. This control group allows you to measure the impact of your experimentation program without the compounding effects of experiments you run over time. Create holdout groups that will run for representative periods of time, typically a quarterly cadence. Add metrics that you plan to measure frequently in other experiments. Add attributes to see effect on broad groups within your target base. And remember, no downside to adding as many metrics and attributes as you can.
Let's take a look at creating a holdout group to measure the impact of experimentation over time. First, we'll create the prerequisite flag. Then we'll add that as a prerequisite to another flag. Then we'll create the holdout experiment itself. The first thing we need to do is create the prerequisite flag, which is very simple. You can see here I've created one called Q4 holdout group. It's very straightforward, and it only has two variations, in holdout or not in holdout. I've also tagged it and added a little bit of information so that anybody looking at the flag will know what's going on. Next, we'll take a look at another flag that's going to actually leverage this. You can see here that I have a typical landing page CTA flag that we'll use for an experiment later, and I'll only need to add a prerequisite to this flag for the Q4 holdout group, and we'll allow people that are not in the holdout to be enrolled in this experiment. Now that that's all set up, let's take a look at setting the experiment that will measure the holdout group's impact on their own. We'll create a new experiment and we'll label it with something that lets us know exactly what's going on here. Q4 holdout group experiment. Measure the outcome of this group. Now, normally we'd put more information in a hypothesis box for a specific experiment, but in this case, it's not exactly hypo-driven, so we'll keep it at that for now. Everything else will be roughly the same. We can add some attributes to see what kind of outcomes we have for other groups within our sample. So let's say user type and maybe user role. We'll then select the primary metric that we'd like to measure for this group across the amount of time that we're looking at, in this case a quarter. We can add additional metrics as well, but of course you need to have at least one metric. Now we attach this to the Q4 holdout group flag, and we set the overall audience. In this case, we only want to add 5% of our overall audience to the holdout group. The other 95% will be considered not in the holdout. And that's it. You're ready to start your holdout experiment.
At LaunchDarkly, we understand how you implement tests vary a ton depending on your tech stack and circumstances. It's one of the reasons we focus on making our platform as flexible and scalable as possible. Here are some tips for executing that any team can use. An AA test presents the same treatment to all participants in an experiment. This serves two purposes. It allows you to make sure that the data you collect is valid, and it also serves as a tool to help prepare all the various teams that will be participating in running an experiment. When experiments are conducted incorrectly, the data is invalid. You lose momentum and, critically, actual time. Here are some practical tips for running an AA test. Plan an AA test as you would any other test. Create a test plan and have all participants review it as normal. This includes choosing a typical update or feature release. Use metrics and attributes your team will commonly use. Run your test for at least 2 weeks. Monitor your results. If you're using data export, this is also a good time to make sure that data is being received as expected. It's important to remember that when experimentation begins to scale, many different people with many different roles will be participating as part of the experimentation practice. Those folks may not have all the context when viewing things like the variation results, and it's important to label these things in a clear and concise way. It seems simple, and it is, but it's going to save your whole team a lot of time and effort. Use naming and numbering systems to help you track in-flight revisions as well as sequential versioning. Add labels or clear names to variations as well as metrics.
Let's look at an example of how naming conventions help as a step in our experimentation practice. Remember that experimentation is by its nature cross-functional, and a lot of this data will flow through to other applications and appear in all kinds of ways with people who may not have the context about what the experiment really was, or that this was even attached to experimentation data. And so we'll use a naming convention at the beginning of the experiment name to make sure that everyone who sees this knows that it's part of an experiment. We'll also use a numbering system because it's quite common to both do revisions and iterations to experiments, meaning that we might restart an experiment just to fix a small error and make a revision. Or we might start a new iteration of an experiment with an entirely different number. We'll also call out what's happening in the experiment as best we can. And add any additional details that might be important when trying to understand what was going on in this experiment, such as the platform it may have been running on.
Anytime you stop an experiment to make changes, LaunchDarkly will automatically create a new experiment iteration for you. All the data collected so far is kept in the previous iteration and a new iteration starts. Don't hesitate to make in-flight changes to start a new iteration. It's common practice to pivot when you learn something new. Moreover, you want to capture valid data as soon as possible. If data is missing, suspect, or just plain incorrect, create a new iteration right away. It's common to start and stop experiments because something has gone wrong and the data collected so far is potentially invalid. Note this in the hypothesis section and update the title to reflect a revision of the experiment. If the audience is being increased, determine if users should be kept in their current assigned variation. The most common reason are experiments that show pricing or navigation changes. In other cases, although it may feel counterintuitive, you are safe to let users be reshuffled. One more reason to reshuffle. Twyman's law states that any figure that looks interesting or different is usually wrong. The other reason to create an iteration can be to replicate results. It's a very good practice to run an experiment more than once, especially if the results are particularly good, interesting, or unexpected. A new iteration of the same experiment will give you the extra confidence in your results by reshuffling users for another round of the same experiments. You may not always know how long to run an experiment for. To help you decide, you should consider the current probability of the winning variation being the best and how long it would take to improve your confidence, as well as the level of risk involved in rolling out the winning variation to all contexts. Experiments with 2 variations display a sample size estimator that gives an estimate of how much more traffic needs to encounter your experiment before reaching your chosen probability to be best. Experiments with more than 2 variations do not display a sample size estimator. With those points in mind, here are some practical tips for determining when to stop an experiment. Try to run an experiment for at least 2 weeks to capture your customers' typical usage habits and avoid things like time of day effect. Incorporate what you already know about your users' habits, like end of month effect. Use our estimator, but don't get stuck on reaching a predetermined probability to be best.
Here in the LaunchDarkly dashboard, we can see the traffic estimator in action. This will show you the estimated amount of traffic needed to reach a probability to be best of 80, 90, or 95% probability to be best for the primary metric of this experiment. All that's needed is at least 100 visitors per variation to have entered the experiment.
Another quick tip. Use attributes of your users to understand outcomes. Use attributes to segmentation of your sample in an experiment. This provides a look at the distribution of your user groups and also some insight into how they performed compared to the overall performance. Compare the posterior mean or conversion rate of the control treatment to your known baselines for that metric. Take a look at the range. It should be close. Finally, you've got a completed experiment in your hands. What now? This can be one of the most important steps for your organization. It's important to tell your data story. Just looking at the numbers won't convey everything you learned. This story has a beginning, middle, and end. It starts with your problem statement and hypothesis. Present your findings regardless of the outcome. All experiments teach us something. Be sure to spend some time describing the problems you identified and you verified. All of this is documented in your test plan. Remember that you were telling a story and the data is a supporting character. Your team can add even more insight beyond that. Finally, make a plan to run your next experiment or make a decision on what you've learned. Thank you for joining me. I hope you learned something and I hope you enjoyed it as well. Stick around because I'll be doing a product demo in the next session.